All right. I hope you checked out yesterday's episode and that you're here for another one today. Consistency is key. So I noticed that some of you are, you're on today, not on tomorrow. But if you if you miss a day, just go ahead and catch up on the previous video and you'll be fine. All right, so today we are doing episode 32, which is questions 34 to 36 of this multiple choice paper that we're doing. All right, and if you've made it this far from episode 21 to now, then kudos to you. I'm happy to have you, and I'm glad that the videos are helping most of you. All right, so our first question for today deals with the concept of circumference. All right, so it says the distance around the edge of a circular pond is 88 meters. The distance around the circular pond is 88 meters. Now, once you hear distance around the pond, around the edge, right? It's going to be 88 meters. You immediately think circumference. And immediately you also start thinking of the circumference formula. So whether you're going to use it or not in the question, let all of these things come to the front of your brain. Okay? All right. So it says the circumference is 88 meters. The radius in meters is, so we are supposed to find out what the radius is. And bravo, we're way ahead. The formula will now help us. So you don't just sit there and try to figure out, okay, how am I going to find a radius if I only know the circumference? Fine, you can. And once you write down the formula, you will see it. Put in now what you know. Do I know circumference? 88 meters. All right, and then you go, 2 times, do I know pi? All right, well, I don't need to be trying to figure out if I need to write 22/7 or 3.14 for pi, because pi is in the options, so I do not need to change pi any at all. 2 pi. All right, and then the radius, we don't know. We want to find the radius though. So what we're gonna do is ensure that r is the subject of the formula. We want radius to be on one side of the equation. All right, so we go ahead and get rid of 2 pi. So how can we do that? It's gonna be division. If I divide one side by 2 pi, I should divide the other side by 2 pi. All right, and so that's gonna be our radius, 88 over 2 pi. Which means our answer is D. All right, moving on. Remember, you can always pause the video. Once the question comes up on the screen, you can always pause the video, go ahead of me, work it out, and then play to see if you got it correct. All right, so here we go. The area of the quadrilateral above is, and the first thing you want to ask yourself is what kind of quadrilateral this? And of course, you are gonna come up with the correct answer, that it is a trapezium. All right, or a trapezoid. Now, it says area, so you're gonna need to know these little formulas. All right, area of the trapezium is gonna be half of the sum of the 2 parallel sides, and generally they're referred to as A and B. Sum of the 2 parallel sides, and while we're at it, let's just identify what sides those are. This one and this one. Ooh, I may not want to be drawing a circle. All right, so these 2 sides are parallel. So area is half times, or half of, the sum of those 2 parallel sides, and one last bit times the height. And here we go. Let's now substitute. That's going to be half times A plus B, 12 plus 8, or 8 plus 12, as long as it's the length of the 2 parallel sides. And the height is going to be definitely not 5. This is called the slant height, or the lateral height. And the height that you really want is this one. Let me use a different color. All right, you want this height, that's the straight height or the perpendicular height. All right, which is a height that meets both of those parallel sides at 90 degrees. All right, so times 3. and then it's going to be half. 12 plus 8 is going to be 20 times 3. 2 into 20 will give us 10. And so we now have 10 times 3, which is 30. And of course, for the units, you would have been inserting your 12 centimeters, 8 centimeters, 3 centimeters. All right, so it would have been 10 centimeters times 3 centimeters, which would be 30 centimeters squared or squared centimeters. And that's it. All right, and our final question for today, this sector AOB. All right, so AOB is a sector of a circle such that angle AOB is 60 degrees and OB is R units long. And questions like these, you want to just reread again so that the information is solidified in your head. All right, so it's a sector, and of course it's called a sector because it's, part of a circle. All right, such that the angle AOB, so we go AOB, so that's this angle right here, is 60 degrees. And OB is R units long. As you can see, this side here, OB is R units long. All right, and of course you can see that where R is, that would have been the radius, OB, the radius of the circle. We're supposed to find the area of this sector. Now, since we're finding the area of the portion of a circle, we are literally doing this area of, all right, hold on, area of the sector equals a certain portion, and I'm going to write that as a fraction, a certain portion of the total area. All right, the total area that would have been for the entire circle, we are finding area, we are finding a fraction of that portion. All right, so here we go. What would be the fraction? Now, we look for ways how we can compare the sector to the entire circle. So the sector measures 60 degrees, the angle right there, AOB, and if we were looking at the entire circle, we know we would have had 360 degrees. All right. And of course, we're now going to simplify. We don't need to know what R is or what pi is because we notice R and pi is constant there in our answers. All right. So all we need to do now is simplify. 60 degrees divided by 360 degrees. And of course, we are going to get 1/6. So our final answer is 1/6 pi R squared, which would be D. And that's it for today's episode. I hope that you'll be back tomorrow. Let me know if this was helpful for you. All right. See you for episode 33. Goodbye.